Hello everyone, this is the second part of lesson 5.1 on exponential growth and decay. As you can see, we're going to use the same growth model and decay model as we did earlier. The only difference between these two is that your base is going to be greater than 1 when you're going to grow, and it will be less than 1 when it's a decay. So if you're ever asked what the percent change is, you need to rewrite your formula in that form. So if your base is 0.75, you need to rewrite it as 1 minus 0.25, and your percent change would be 0.25. Okay? So let's go ahead and talk about writing this time. So we have, in 2015, the world population was about 7.38 billion. During the next 5 years, the world population increased about 1.09% each year. Write an exponential model that represents the population in T years after 2015, and then we're going to estimate the world population in 2020. So if we're going to write a model, the first thing we need to do is figure out, is it a growth or is it a decay? Well, there's a key word in here. It says that it has increased by 1.09%. So that means that this is going to be a growth. So if it's a growth, what you want to do is you want to write down the generic model for growth, which is this one. All right, next part's really important. What's the initial amount? So the initial amount was 7.38 billion. So we're going to leave it a decimal, 7.38. We just have to remember that it's in billions. And then the percent increase is 1.09%. Now I'm going to write it down as a percent first, but then I need to change it to a decimal. So the decimal is what we're going to be using in our formula. So to change it to a decimal, we just move our decimal place 2 places to the left. So it's going to be 0.0109. Very, very small percent. All we're going to do is we're going to replace your original amount, which is A, and this is our percent change, which is 0.0109. So I'm going to put A equals 7.38 parentheses 1 plus 0.0109 to the power of t. Now this is your model, okay? But you're probably going to want to go ahead and add it together because your final answer should look like this. The only reason why you would want to leave it as 1 plus or minus if they're asking you to find the percent change. But in these questions, they're actually giving them to you. Okay, so let's talk about how we're going to use the model that you just wrote. It says to estimate the world population in 2020. Well, if it wants us to estimate the world population, is that T or is that Y? The world population is Y. T is the time or how many years after 2015. So if they want us to estimate how many years or how the population in 2020, that is 5 years after 2015. So what I'm going to do is I'm going to substitute. So I'm going to plug in a 5 here, and then I'm just going to type that into my calculator, and I wind up with 7.79 billion. Now this is just an estimate, but it's good to use our model for estimating. Okay, so in the second example, I think that if you are feeling confident or if you just want to try the question out, I think that you're able to do this whole side. I would pause or I would at least wait until I explain the second part of it. But if you want to try it on your own, go ahead and pause the video and we'll see how you do. Okay, so this one is talking about cell phone subscribers since the year 2012. And it said there were about 6.26 billion cell phone subscriptions in the world. And during the next 5 years, it increased by about 4% each year. So if it says increased, this is going to be a growth. And we're going to use the same model as we did before. This time using Y. And then I'm going to write down the two things that I need to write a model. That's going to be the initial amount, 6.26 billion, and the percent increase is 4%. All you have to do is change that into a decimal before you plug it into your formula. So my model is going to be 6.26, and then 1 plus the percent change, and then you need to go ahead and add those together for your final model. There you go. And what we're going to do is we're going to use this model to help us estimate when. So this one's different because it says when. Now, on the last one, we were trying to figure out total after so much time. So this one's going to be different. I'm not going to plug it in for t for time. I'm actually going to use 7.5 over here for y. So what I'm going to do is I'm going to write down 7.5 equals y. And the reason why I'm doing this is because as it is, you don't know how to solve the exponential equation if I'll go ahead and plug it in. So it would look like this. And yes, you're going to eventually learn how to solve that. But we all know if we type this in like this in Desmos, it's not going to give us an answer. So it's better for us to go ahead and type them into Desmos separately. So this is going to be your first one. And we want to see where this line intersects our model. And that's going to give us our answer, or at least a clue to the answer. Okay, so let's talk about Desmos for a second. So when I typed in y equals 7.5, I can't see it because it's not in the home screen. So I'm going to drag this down just a little bit. There it is. So the 7.5 is the red line, and my model is the blue line. I want you to notice that I put an X here because Desmos understands X. So I'm going to go over here, and this right here, oops, this is what I'm looking for. I'm looking for that intersection point. So X is 4.6 when Y is 7.5. So that basically means T, or time, 4.6, and it's in years. So 4.6 years, we're going to wind up with 7.5 billion subscribers. 4.6 years. So time is going to be 4.6 years, but it's asking when. So when did our time start? Our time started in 2012. So just count 2012. And we're going to add 4 to that. So 2012 plus 4 gives you 2016. Now, I'm not going to worry about the 0.6 because 0.6 just means it's a little past halfway in the year 2016. And we're all done with that one. Okay, so now we're going to talk about compounded interest. You've seen this formula before. One more time, good news, this is on your formula sheet. You do not have to have it memorized, but you do need to know how to use it. I do need to point out that N is used twice in this formula, and N is going to change depending on how often that it is compounded. So yearly would be 1, quarterly is 4, monthly is 12, daily is 365. You will be using that in this lesson and then the next lesson, and possibly later on in the chapter. Okay, so it says you deposit $9,000 in account. So you need to understand that this is your principal. This is how much money that you are spending or actually depositing into your account. Oh, and by the way, just for fun, this is not spelled A-L. It's P-L-E. Gotta love autocorrect. Well, anyway, so P, your principal, is going to be 9,000. And then you're going to go ahead and write everything else like you normally would. Your rate is going to be 0.0146 because you're going to move your decimal 2 places to the left. And then it says you're going to find the balance after 3 years. T is equal to 3. And then it is compounded quarterly. So quarterly is 4. Now, all you have to do is you have to plug this into your formula. So let's look at the formula. It's right above it. So your principal is 9,000. 0.0146. Make sure you change it to a decimal. N is 4. And a lot of people will forget to put your N also as your exponent times 3. Now, if you're using a scientific calculator, it's going to be pretty easy, but I'm going to warn you, if you use Desmos, make sure that you put parentheses around that or it won't let you do both 4 times 3. Okay, so if you type that in your calculator, you may want to check to make sure that you can do that. You should round it to the nearest cent. So it's going to be 2 decimal places because it is money. And that's how much money you have in the bank after 3 years, compounded quarterly. Okay, the second question is something that you definitely want to try to work on your own. It's very much like the last one. So go ahead and pause the video, write it down, fill out all of your stuff, and put it in your calculator, and then check your answer with my work. Okay, so I got $525.63. It is a little bit different because it says it's compounded daily. So that's your 365, which goes here and here. But everything else is basically the same thing. So just let me know if you have any questions on that one. Now, if you're a regular Algebra 2 student, you need to go ahead and stop watching the video because you're done with this lesson. But if you're honors, go ahead and continue to watch the video and learn how to rewrite an exponential function. So honor students, we're going to be doing this regularly throughout the chapter, and it may very well wind up on your benchmark. So what they're wanting us to do is manipulate this equation here, and you notice it says y equals a, and it doesn't give us like our original amount. It just tells us that our decay is going to be 0.5. So what I'm going to do is I'm going to make a statement. I'm going to say that that is a decay. Since it's a decay, what we want to do is we want to write it in the form of decay. So if you see, it's actually got t divided by 28 as the exponent, okay? So what I want to do is I want to take that 28 and I'm going to change it. I'll show you right here. So t over 28 is the same thing as t over 28, and there is a 1 in front of that t. And you can separate that. You can say that that is equal to 1 over 28 times t. That's what you've got to do. So I'm going to write 1 over 28 times t. Once you do that, then you're going to use power to a power, but it's the opposite of what you're used to. You are going to take that 1 over 28 and you're going to include that inside the parentheses. So it kind of looks like a problem that you would be given here, and then you go back and then you multiply these two. So it looks backwards. Then you're going to use your calculator and you are going to simplify this base because that is going to give you the rate that you are looking for. So when you type it in your calculator, you get 0.9755. It's still going to be decay. It's just very clear as to how much you're going to lose. Now remember, we're almost here. We want to write this as something 1 minus. So 1 minus what number gives us 0.9755? Just take your calculator and do 1 minus 0.9755. And you wind up with 0.0245. The reason why we do that is because we are answering the question, what percent decays each day? We couldn't really tell that before. Now I can because I'm looking directly at that rate. So the rate in percent form would be 2.45%.